Welcome everyone. I am Pabido Macmillan from CSE. Let's begin. How does carbon nanotubes reducing power loss in transmission wires? Introduction. Power flows in some of the transmission lines are overloaded, which has an overall effect of deteriorating voltage profiles and decreasing system stability and security. In addition, existing traditional transmission facilities in most cases are not designed to handle the control requirements of complex and highly interconnected power systems. This overall situation requires the review of traditional transmission methods and practices and the creation of new concepts which would allow the use of existing generation and transmission lines up to their full capabilities without reduction in system stability and security. Nanotechnology is a popular current research area that has the potential to significantly change the electric utility industry. There were a lot of possible applications to improve electrical, mechanical, thermal, or chemical properties of electric power equipment. Carbon nanotube wire product, also called armature quantum wire, for the type of nanotube best suited for the process, has been estimated to have the potential to increase grid capacity by perhaps a million times numerous nanomaterials and other nano related applications relevant to electricity transmission are in various stages of research, development, and deployment. The application has the potential to directly or indirectly reduce the environment impact associated with the construction, operation, and dismantlement of electrical transmission technologies. Nanotechnology may help improve the efficiency of electricity transmission wires. Contents. What is a carbon nanotube? Type of carbon nanotubes. Properties of carbon nanotubes. Applications of types of carbon nanotubes. Potential application of carbon nanotubes. What is a carbon nanotube? A carbon nanotube is a tube-shaped material made of carbon, having a diameter measuring of the nanometer scale. Carbon nanotubes are formed from essentially the carbide sheet, and the carbide layer appears somewhat like a rolled up, continuous, unbroken hexagonal mix and carbon molecules at the apexes of hexagons. Nanotubes are members of fluorines structural family. Their name is derived from their long, hollow structure with the walls formed by one atom thick sheets of carbon called graphene. Types of carbon nanotubes and their applications. Carbon nanotube. Carbon is the most prevalent element is not only our universe, but it also forms the basis of life forms on Earth. Carbon is thus essential to man since the very beginning in its varied ways, from our fuel to our food. Carbon is necessary for us to survive and prosper. One of the most useful recently discovered forms of carbon are carbon nanotubes, also known as carbon nanotubes. This is an allotropic form of carbon which is naturally in a microscopic cylindrical structure. Today, these studies have revealed amazing and incredible properties of these carbon allotropes. Besides, two types of carbon nanotubes can be synthesized. Each class has its specific qualities which are used in numerous industries. Types of carbon nanotubes. Single walled carbon nanotube. Single walled carbon nanotube is a cylinder formed with only one layer of carbon molecules. Commonly, these have fabricated in diameters ranging from 0.4 to 2 mm. The diameters of single walled carbon nanotubes determined by the range of temperature at which they synthesize. Increasing temperature results in larger sized single walled carbon nanotubes have incorporated. The structure of single walled carbon nanotubes may vary and may either be zigzag, helical, armature, or spiral arrangement. The surface area of single walled carbon nanotube is also considerably higher at 1300 m power 2 divided by g, which makes it ideal for nanorobotics and future of medicine administrating. Multi-walled carbon nanotube. On the other hand, multi-walled carbon nanotubes differ with single-walled carbon nanotubes by the number of cylindrical walls they have. In multi-walled carbon nanotubes, the carbon molecules from multiple concentric walls of consequently increasing diameters around one another. Although there are numerous walls in multi-walled carbon nanotubes, each wall is composed on an atom-thick structure only. Properties of carbon nanotubes. These are the intrinsic properties of carbon nanotubes, single walled and multi walled, which makes them excellent prospects in numerous industries. It is ideal conductors of electrical energy, higher tensile strength, extraordinarily flexible and electric. It is excellent conductors of thermal energy, high accept radio, excellent electron field emitters, lower thermal expansion coefficient. Applications of types of carbon nanotubes. These are the various applications in which single-walled carbon nanotubes are valuable in different industries. Applications of single-walled carbon nanotubes. These are the various applications in which single-walled carbon nanotubes are useful in different industries. As additives in the polymer for increased strength and electrical conductivity at the same time, as catalysts in several chemical reactions for better controlled reactions and best results, as emitters of electron fields perfect for cathode ray lighting devices, as a more efficient material for flat panel displays, as gas discharging tubes in telecom networks. Applications of multi-walled carbon nanotubes. Multi-walled carbon nanotubes are strong, have better electrical and thermal conducting capacities, and this find broader potential in following ways. The use of multi-walled carbon nanotubes in batteries can double storage power. In solar cells, as multi-walled carbon nanotubes based solar cells have 100 micrometer high towers that absorb remarkably more sunlight comparatively, thus ensuring significantly higher power generation. In transistors, where the size would be remarkably decreases even further, resulting in more compact and micro versions of electronics nano electronics for flat panel displays. As a global electronics brand, Samsung has already fabricated a field emission display with multi-walled carbon nanotubes strips on the cathode and phosphorus coated ITO strips on the anode. In case of better energy storage, multi-walled carbon nanotubes are more powerful electrochemical capacitors as compared to other forms of carbon. Potential applications of carbon nanotubes: energy storage, field emission devices, transistors, AFM tips, nanotubes, composite materials, nanostructures, potential for extremely strong light weight cables and space elevator, physical memory. Conclusion: the applications of carbon nanotubes in the field of energy conversion and storage, environment monitoring and wastewater treatment, as well as green nanocomposites design or research area of growing interested from their potential usage in for future technologies point of view. This review examines the attributes of carbon nanotubes as the electrode material or conductive filter in the electrochemical devices of energy applications. The potential development of carbon nanotubes as sensing material in nanosensors for environment monitoring. In addition to the development as absorptions to remove pollutants in wastewater treatment are discussed. The advantages imparted by carbon nanotubes in green nanocomposite materials and their impact on the environment are explained in the last section. Thank you.